in question 24. Our master vectors here are A and B, and this length is twice this vector. And we're told that the point P is such that the line C, E, and then P is a straight line such that this bit of the line is equal to this bit of the line. So this is the point P. So I've indicated that both the sections of this line are equal. Use a vector method to prove that CF, which is this vector here, is parallel to DP, which is this vector here. Well, to prove these two lines are parallel, we need to travel along them and quote our travel in terms of other vectors. CF, I can travel along CD, then back down along DE, and then back down along EF. So I can quote CF already. So let's write that down and get that out of the way. CF, the journey from C to F, is equal to 2A. We're going the wrong way down vector B, so this is negative vector B, and then we're going the wrong way along vector A here at the base. So this is negative A. That simplifying, the A's will mix, so we get A minus B. And that's the first important result. Okay, if we attempt to travel down DP, I can't do it because I need to know what this vector is, EP. Well, we're told that it's the same as CE, so I can say that travelling along EP is the same as though I was travelling along CE. So first of all, CE is equal to, yes, I can travel along other lines for CE. This will be 2A minus B. No simplification goes on. And as I said, this is the same as travelling along EP. So now I can travel along DP because I can say that DP is equal to negative B plus the vector we've just worked out. So this is plus 2A minus B. Pulling the B's together, we get 2A minus 2B. And that's the second important result. Now, are these lines parallel? Well, yes, they are, because I can take a common factor of 2 out of dp, and this is equal to 2a minus b. So it's just double the length of our vector CF, but it's in the same direction. So therefore I can say CF and dp are parallel. And there's your answer.